This is a chemistry video. This is the last section. This video is on the last section of chapter 4 of a chemistry textbook by Brown, LeMay, Burston, and Murphy called Chemistry, the Central Science. But of course, all chemistry textbooks are going to cover this question. This section is basically about what we call titration. Titration is a method, and I've got a nice little titration device behind me here. Titration is a method for finding out what the concentration of, say, an acid is or a base is, or it could also be some um, aqueous solution that is susceptible to a redox reaction. The chapter 4, is on aqueous reactions and the stoichiometry of solutions. Stoichiometry has to do with the way things balance out on two sides of a chemical reaction. And so this video is about how we do that kind of analysis. It's a very practical section in a way because it has to do with a certain kind of experimentation that we do to try to figure out what the concentration of a solution is. Of course, if you're going to measure the concentration in this way, you've got to destroy the concentration. So I assume you're taking a sampling of it. Anyway, let's get into this. Moles are the key because matter is neither created or destroyed, right? It's one of the laws. And so when a reaction takes place, you're going to have the same number of moles of substances after the reaction as you had before the reaction. So when you want to figure out things like how many grams of this I have or how many liters I have before and after a reaction, knowing the moles of something and then knowing the equation is going to allow me to figure out what the unknowns are of that particular reaction. And again, the basis for figuring these things out is the fact that matter can neither be created or destroyed. So the number of moles of stuff, elements, before the reaction and the number of moles of stuff after the reaction is going to be the same. And that equation is going to make all the difference. So I mentioned that this is a video about, and that this section is primarily about titration. And in titration is an experimental method to find out the concentration of a particular solute in a solution. Liquidy stuff in liquidy stuff. So the solute is the lesser liquidy stuff in the solution, which is the bigger liquidy stuff, usually water. Okay, so titration is a method. And what you do is, so for example, if you're trying to find out what the concentration of a certain acid is, you're going to drip a base into it until it reaches what's called an equivalence point. That's where it's neutralized, and it's not acidic or basic, but it's right in the middle. And so if you're trying to figure out the concentration of an acid, you drip base into it using a burette, like I have behind me. A burette. It's not a burette. That would be French. But anyway, you drip the opposite. So if you want to find out the concentration of the base, you drip acid into it until it's neutralized. And you can also do this with redox reactions. Now, key to this is you use some sort of standard solution. So if you're, for example, trying to figure out the concentration of an acid, you might use a standard solution of sodium hydroxide, which is a base. Or if you're trying to figure out the concentration of a base, you might drip sulfuric acid or hydrochloric acid into it. Okay, use some standard solution in order to neutralize the acid or base, and that gives you a tool for knowing the concentration. So you're going to also use some sort of an indicator. There are different kinds of indicators. Phenolphthalein is a common indicator. When something is acidic, it's clear. If something is basic, it turns pink. And so you can tell when something is neutralized by the equivalence point where the solution starts to go from being acidic, clear, to being pink, basic. You know, you've reached the equivalence point. Obviously, there's a kind of imprecision to this. And this is where people like me who are very good at theoretical things, you want to keep me out of the laboratory, unfortunately. But that's another story. All right, let's end this video with an example. So here's one of the questions that's it gives the answer, but it doesn't tell you how to get the answer. So I'm going to show you how to get the answer. So one of the examples asks, what is the molarity of a sodium hydroxide solution if 48 milliliters neutralizes 35 milliliters of 0.144 molar sulfuric acid? Okay, or molar, we've learned, is moles per liter. All right, so let's do this thing. So the imbalanced equation, first let's figure out what the equation or what the reaction is. So we know we're starting with sodium hydroxide and we are titrating into it, drip, 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 using a burette, maybe, sulfuric acid until it's neutralized. So what is the equation here? So we know we've got sodium hydroxide and we've got some sulfuric acid, and it's an exchange or metathesis reaction. So the sodium, they're swinging your partner, they're going to switch partners. The sodium's going to hook up with the sulfate, and the hydrogen is going to hook up with the OH and form water, H2O. Okay, so we want to balance it. So what is imbalanced here? Well, I know that sulfate, so hydrogen is 1 plus, right, in its charge. And so we've got two plus here. So sulfate must be 2 minus. So I've got a 2 minus here, and I know sodium is 1 plus. So I got to have 2 sodiums in order to balance out the 2 minus charge of the sulfate. So I know I'm going to have to put a 2 in front of this. So 2 and 2, I've figured out using the charges. Now, if I've got 2 hydrogens here, and I've got 2 hydrogens here, then I'm going to have 4 hydrogens here. So I'm going to put 2 in front of that. So the balanced equation looks like this. Everything evens out now. It's a balanced equation. 2 sodiums here, 2 sodiums here. I've got 2 plus 4 is 6 oxygens. I've got 2 plus 4, 6 oxygens. 2 hydrogens plus 2 hydrogens. I've got 4 hydrogens. It's a balanced equation. So here's the nice balanced equation. All right. So to be continued. Now we've been told that we have a 0.144 molar solution of sulfuric acid. So molar means moles per liter, right? And we are told back in the question that it takes 35 milliliters of sulfuric acid for it to balance out. Okay, so 35 milliliters is 0.035 liters. So moles per liter times liter gives us moles. So 0.005 moles of sulfuric acid is what we've got. Well, if you look in the balanced equation here, there are 2 sodium hydroxide molecules for every 1 sulfuric acid molecule. So I'm going to have twice as many sodium hydroxides as sulfuric acids in this neutralization. So multiply moles times that ratio, and I find out that what I have neutralized is 0.01 moles of sodium hydroxide, okay, by that equation. Okay, now we're very close to the end now, because I was told back here that we have this is how much it takes. It takes 48 milliliters to neutralize the sulfuric acid. So we basically divide the moles per liter to get the molarity. So we have 0.01 moles of sodium hydroxide, and we have 0.04 liters of sodium hydroxide. That means that the concentration of the sodium hydroxide solution is 0.21 molar solution of sodium hydroxide. So that answers the question here. What is the molarity of a sodium hydroxide solution if it takes that much to neutralize that much of this molar sulfuric acid? And the answer is 0.21 molar sodium hydroxide. All right, so there we have, to end the year. This is my last chemistry video of the year 2020, and it is the last video in chapter 4 of Burston, LeMay, Brown, and Murphy, not in that order, chemistry, the central science.